Hello everyone, this is Mr. McMillan, and I'm here with an instructional video / example video on the Pythagorean theorem and special right triangles. So these 8 problems are on the Google Classroom in a blank document along with the worksheet that I am going to have you be doing today. The worksheet itself is 12 questions, and it goes over some of the problems similar to what you might see on a quiz or a test. Okay, so let's look at number 1 here. Number 1 says, for the triangle below, what is the length of line segment XZ? Round your answer to the nearest tenth. So anytime that you do any of these problems, you need to make sure that you identify first off, how many sides you have, and if you have a special right triangle or not, and then how to best set up the equation. So in this case, we can see that we have sides XY and YZ labeled. So that means we have 2 sides. Now we can't say whether we had a special right triangle or not, because there are no angle measures in here for us to tell. So we wouldn't be able to tell if that's a 30, 60, 90 or what it would be. Okay, so we just have to go based off of these side lengths that we have. And specifically, do we have legs or do we have hypotenuse? Well, remember that your hypotenuse is always opposite the right angle. So it's always opposite the right angle, okay? So that means that if we draw an arrow to the side that's opposite from the right angle, the one that's not touching, we're missing that hypotenuse. So we have our 2 legs. And you can tell these are legs because the legs always touch the right angle. They're adjacent to the right angle. Okay? So when we're dealing with right triangles, we're going to be using the formula a squared plus b squared equals c squared. Now we have to determine what our a, b, and c values are. Well, since we're missing our hypotenuse, and C is always labeled as the hypotenuse, we don't know what C is. We do know what A is. Normally I say that A is the short leg. So A will be 7.8. And then I know what B is, which is 11.5. So now all we need to do is we need to plug those in to our equation that we have set up here. So a squared plus b squared becomes 7.8 squared plus 11.5 squared, and then equals c squared. So I'm going to get my calculator up here, just a basic calculator. And if we take 7.8 squared, we get 60.84. And then plus 11.5 squared, which is 132.25, and that's equal to c squared. C squared's already by itself, but we need to combine the terms on the left side. And so we get 193.09 equals c squared. Now, we still need to do one more step. We're not quite done yet. And the reason we're not quite done yet is because the c is not by itself yet. It has a squared. It has a squared term with it. So just like when you're solving equations normally, you need to make sure that you do the opposite of that squared term to get rid of it. And the opposite of a square is a square root. So we're going to square root both sides. And we get that, well, we'll take the square root of this. So the square root ends up being 13.89568, so on and so forth, is equal to c. Now, we don't want that big long string of numbers after the decimal place, so we need to make sure that it tells us what we need to round our answer to. And in this case, it says round your answer to the nearest tenth. And the nearest tenth is 1 decimal place, which would be here. But there's a 9 behind it, so we have to round the 8 up to 9. So 13.9 is equal to C. So that's what XZ is. All right, now let's look at number 2. Number 2 says for the triangle below, what is the length of line segment AB? So the same process we did before. We're looking, we have a right triangle, and we need to determine if it's a special right triangle. There are no angle markings, so we can't tell if it's a special right triangle. So then we move on to make sure we have 2 sides. And indeed we do. We have 21 here and 35 here. So we know we're going to have a squared plus b squared equals c squared because it's a right triangle and we're trying to find the length of AB. Well, let's look and see what we should label AB. Should we label it with an A, B, or a C? And that all depends on whether it is a leg or hypotenuse. And as we can see here, side AB touches the right angle. And so that means that side AB is one of the legs. Now, it honestly doesn't matter if you label it, which letter you label it with, as long as you don't label it with C, because C is always the hypotenuse. So C is 35. I'm just going to label AB with A and then BC with B. Okay, I don't know if it's the short side or not. I'm just labeling it with an A for convenience sake. Okay, so we're looking for A. So we're going to have A squared, because we don't know what A is, plus B squared would be plus 21 squared, equals C squared, which would be 35 squared. Now we're going to simplify this. The A squared drops down. 21 squared is 441. I did not mean to close out the calculator. I'm sure it'll, yeah. 35 times 35 is 1225. Now, A squared is on this left side here, and it makes no sense to move it over to the right side, so we need to get rid of this 441 instead. So to get rid of that 441, we're going to subtract it from both sides, and we get that A squared equals 1221 minus 441, which is 784. And again, we find ourselves with a variable squared, so we have to do the opposite to get rid of it. So we're going to have to square root A squared, and what you do to one side, you have to do to the other. So A is going to equal the square root of 784, which is 28. So that means that AB is equal to 28, and that would be our answer. All right, number 3. Number 3 wants us to classify the following sets of side lengths as acute, right, or obtuse. You may use all of these, you may not use all of these. We're just going to have to determine what we need to do. So let's look at A. So to figure out whether these are acute, right, or obtuse, we have to use the Pythagorean theorem. But the thing is it's going to be tweaked a little bit. So we know that if A squared plus B squared equals C squared, this is a right triangle. However, if we find out that A squared plus B squared is larger than C squared, so in other words, C squared is small, that means this is acute. And likewise, if we find A squared plus B squared is less than C squared, that means C squared is real large, then this is obtuse. So let's look at A. So we have 12, 16, and 20. Remember, we're trying to find our A, B, and C value. C is always your largest side length. So in this case, it is 20. So we're going to put a C over 20. And then A would be our shortest side, which is 12, and B would be 16. So we do A squared plus B squared, and we're going to do C squared in a bit. So A squared plus B squared is 12 squared plus 16 squared, which would be 144 plus 256, which is 400. Okay, now that we know A squared plus B squared, we have to figure out C squared to compare it to it. So we have 20 squared, and if you take 20 squared, you get 400. Since 400 is equal to 400, we look at our rules here, and that would mean that it is a right triangle. And now we're going to do the exact same thing for B and C. Okay, so B, you have 12, 8, and 6. Your largest side is 12, so that's your C value. Your smallest side is 6, and your medium side is 8. So A squared plus B squared becomes 6 squared plus 8 squared, which is 36 plus 64, which is 100. And then 12 squared becomes 144. We don't need this calculator right now. C squared becomes 144. And is C squared smaller than, equal to, or larger than 100? The answer is that C squared is large. So that means this is obtuse. And then C, we have 4, 5, and 6. Our C value is our longest side, so that would be 6. A is our shortest side, which would be 4. That leaves 5 to be B. A squared plus B squared. A squared plus B squared gives you 4 squared plus 5 squared. 4 squared is 16. 5 squared is 25. 16 plus 25 gives us 41. Then we take C squared, which is 6 squared, which is equal to 36. And 36 is smaller than 41, so that means that we have an acute triangle. All right. Number 4, would the following side measures for triangle SRM form a right triangle? So it gives us SM equals 14, RM equals 17, and SR equals 21. So all we're concerned about is determining whether this would form a right triangle. And so our answer is either yes or it's no. Well, if we're trying to figure out if these side lengths would form a right triangle, we need to use the Pythagorean theorem. So we need to figure out what our A, B, and C values are. Our A value is 14 because it's the shortest side. Our C value is 21, and B is 17. So we're going to do A squared plus B squared, and we're going to see if it equals C squared. And we have to see if it equals C squared because this says which would form a right triangle. So A squared becomes 14 squared plus 17 squared. 14 squared is 196. 17 squared is 289. And so this becomes 485 when you add those together. Now we do C squared. C squared is 21 squared. And if we do 21 squared in our calculator, we get this as 441. Does 485 equal 441? The answer is no. So this is not a right triangle. Okay. All right, number 5. Number 5 says, what is the length of the diagonal of a rectangle that is 9 feet wide and 12 feet long. Okay, so we have a picture of a rectangle with a diagonal. Now remember that the corners of a rectangle are all equal to 90 degrees. The angles inside are all 90 degrees. So this diagonal splits it into two congruent right triangles. So we want to find the length of the diagonal. Well, the diagonal, since this is a right triangle, our diagonal would be our hypotenuse C. So we're looking for C. And it says of a rectangle that is 9 feet wide and 12 feet long. So it doesn't really matter. Typically I use the long for this way and then the wide for this way, but you know, it is what it is, whichever way, as long as you're labeling the legs and not the hypotenuse with anything. So 9 feet and then 12 feet. And since these are legs, we can label these with A and B. A will be 9 and B will be 12. This isn't a special right triangle, so we just use A squared plus B squared equals C squared. A squared is 9 squared, B squared is 12 squared, and we don't know what C squared is. 9 squared is 81, 12 squared is 144, equals C squared. 81 plus 144 is 225. Square root both sides to get rid of the square on the C, and this is 15. So our length of our diagonal is 15 feet. All right, number 6. It says an equilateral triangle is folded in half. The important thing there is it's an equilateral triangle, okay? So an equilateral triangle has all sides to be congruent. So even if you don't know all 3 sides, if you know one of the sides, you know what the other sides are. And in this case, we do know that the base of this equilateral triangle is equal to 16 centimeters. So we know these other 2 sides must also equal 16 centimeters because it's equilateral. Then it asks, what is x, the height of the equilateral triangle? Now, what you're going to notice here is that this is a 30, 60, 90 triangle. But because it's an equilateral triangle that's folded in half, there's actually 2 different ways to do this. We can use the Pythagorean theorem, since we'll know 2 sides, or we can use the properties of 30, 60, 90 triangles. I'm going to do it both ways. I'm going to do it with the Pythagorean theorem first, and then the 30, 60, 90 properties. So it also says the equilateral triangle is folded in half. So it's folded in half. If the base is 16 and we fold that in half, this is our halfway mark. Half of 16 would be what each of these sides are. So we know that each of these sides would have to be 8 centimeters because it says it's folded in half. So if we're using the Pythagorean theorem, we now have 8, 16, and we're looking for x. So which sides do we have? Well, if we look here, we see that 8 is on a leg because it touches the right angle. And 16 is the hypotenuse because it is opposite of the right angle. So we know that our C value is 16 and our A value is 8 and our B value is x. So A squared plus B squared equals C squared. A squared is 8 squared. We don't know what B squared is, so we're going to put an X there. And C squared is 16 squared. 8 squared is 64 plus X squared equals 16 squared, which is 256. We're going to have to subtract 64 from both sides, and we get that x squared is equal to 192. We have an x squared here, so we have to square root both sides, and we get that x is equal to the square root of 192, and this actually simplifies to 16 root, or not 16 root 3, excuse me, 8 root 3. This breaks up into 64 times 3. 64 breaks up into 8 and 8, so it can be pulled out, and you get 8 root 3. So we know that x is equal to 8 root 3 centimeters. Okay. The other way to do that was with the 30, 60, 90 triangle properties. Since we know this is a 30, 60, 90 triangle because of the 60-degree angle, we knew what our short leg was, and our formula for the long leg, which is what x is labeled as, is long equals short times root 3, which is equal to 8 times root 3. So that would have been what x was equal to, and that's what we found when we did it with the Pythagorean theorem. All right, number 7. Number 7, it says for the triangle below, determine the values of x and y. Okay, so for the triangle below, determine the values of x and y. Well, if we want to determine the values of two different sides, then we can't really use the Pythagorean theorem, at least not to start with, because we're probably dealing with a special right triangle. Okay, so if you're given two sides, you can use the Pythagorean theorem of a right triangle. But if you're only given one side, you have to see if you have a special right triangle. Otherwise, you can't find what we're dealing with, at least not at this moment, not until we get into the next thing. Okay, so here we're looking to see if we have a 45, 45, 90 triangle or a 30, 60, 90 triangle. And you can tell that we have a 45, 45, 90 because of the 45-degree angle there. And the properties of a 45, 45, 90 triangle, the legs are equal, first off, and then the hypotenuse is equal to the leg times root 2. Those were the formulas we talked about the other day. So let's see, do we have a leg or a hypotenuse in this case? Well, in our case, we have a leg. 8 is our leg. So since the legs are equal, our other leg would also be 8. So x, which touches the right angle, would have to be 8. So now we can figure out our hypotenuse, and our formula is hypotenuse equals leg times root 2. The hypotenuse is y. The leg is 8 times root 2. This can't be simplified any further. It's already as simple as it gets. So y is equal to 8 root 2. Okay. And the last one of the example problems, number 8, for the triangle below, determine the values of A and B. So if we look at A and B here, since we're missing two sides, we need to figure out what type of special right triangle we have, if any. And we can see that we have a 30, 60, 90 triangle because of the 60-degree angle. Okay. Now, the important thing is in a 30, 60, 90 triangle, we always want to know what our the short side is, because we can use it immediately to figure out the hypotenuse and the long leg. But in this case, what we have is the hypotenuse, not the short leg. So we want to find the short leg first. Well, the relationship between the hypotenuse and short leg of a 30, 60, 90 is given by the formula hypotenuse equals short leg times 2. Our hypotenuse in this case is 22. Our short leg is B because it's opposite the 30-degree angle, and then times 2. To solve for B, this is being multiplied by 2, so to get rid of it, we need to divide both sides by 2. So we get that B is equal to 11. Now that we have our short side, we can find our long side since it's the only one remaining. And while you could use the Pythagorean theorem, you also can use the rules for 30, 60, 90 triangles, which state that your long leg is equal to your short leg times root 3. Your long leg is A, and your short leg is what we just found, which is 11, and then times root 3. So A would equal 11 root 3. Okay, and that's going to do it for this video, guys. These were 8 example problems, mostly things that you would see on a quiz or a test. On the worksheet, there's a couple other things, but for the most part, they're all relatively similar in structure. Okay. If you have any questions, please make sure to email me, ask questions during the Zoom. We can't help you unless you ask questions. Okay. Thanks, guys, and I will see you in the next video.